If you want logged in users of your website to have different permissions so that they can access different parts of your application or even your backend API, then you've come to the right place, because today we are going to be dealing with user roles with Azure B2C. Good morning, good afternoon, and good evening, whenever it is that I find you, and welcome along to the channel. So if you Google for Azure B2C and user roles, you'll find generally a whole lot of negativity around things that it says it doesn't support user roles out of the box. And while that's true, there is a mechanism in Azure B2C that we can utilize for this purpose, and that is API connectors. So what are API connectors? So the way that Azure B2C works is our authenticating user goes across to, or gets redirected to, Azure B2C. Azure B2C can then call out to an API. So this API has got some constraints. It must be a public endpoint, and it must also be an HTTPS endpoint. So it's got to have a certificate installed. But this API function essentially adds extra claims that it passes back to Azure B2C. So it can be any custom data that your particular API wants to inject into the user's credentials, essentially. And they get injected into the token that then gets sent back to your front end. But there's a problem, because it's all great when it's up and running, but how do we develop this locally? So for the local situation, we've got Azure B2C still, and we've got our public endpoint. So we can use our API that we publish up to Azure as part of our application. And we can actually put a reverse proxy function into that API. And that reverse proxy function can then call our local development machine that we've exposed out onto the internet. And that can do our custom claims at that point, pass it back through the reverse proxy back to Azure B2C and into the ID token and the access token. This means that we can develop locally and work out what our claims should be and get all that code working before we then publish that up to our public API, so that what it looks like when we move to production is that we remove that reverse proxy function, we reconfigure Azure B2C to directly call our function that just adds our claims that we've been developing locally, but now it exists in our public API because we've pushed that up. And so this is what our production architecture then looks like. We could choose to remove that reverse proxy function at that point, but obviously you may want to develop again locally to add enhancements to that particular function. So it might be useful to have that still inside your API, your decision. So let's go and dive in and see how we can set all of this up. But the first thing that we're going to have to set up is being able to access our Azure function locally, but from the internet. So I'm on my router here, and you can see that my local Azure functions run on an internal IP address on port 7071, which is usually the default for Azure functions in a development environment. And you can see that I'm port forwarding here from my external port on port 888. So any request that comes into my internet IP address on port 888 will forward across to my Azure Function API. How you go about setting this up is going to be a unique situation for you. There's all sorts of weird and wonderful ways that people set up their development environments these days, so I'm going to have to leave this step to you, but this is what works for me. So with that exposed, we can jump over into VS Code, and we can go to our API, now API functions, where we have all of these. And the first thing that we're going to do is set up this reverse proxy function that we're going to publish up to our publicly exposed API. So let's create a new Azure function in here, which is our simple reverse proxy, called simple reverse proxy. It takes gets or posts. And what we need to do in here is we're going to take the name of the function that we want it to proxy across to on the URL as a query argument. So that's why we're using this query parameters dictionary here that I've got in a utility function here in this query parameters dictionary. So this gets the query parameter and teases those out into a dictionary such that I can then query for a given value. So I'm looking for a func query value on the URL. So we need somewhere where we can store our response body as well. Then we'll have some error handling. So if func to call doesn't actually exist on the URL, then we'll just return an error, a bad response, or bad request rather. And then what we're going to do is pull the configuration for where our actual API is that we want to proxy across to. So in our case, it's our local host one, but it's going to be our internet facing address on that port quadruple 8 for me that I'm going to configure into this proxy API host environment variable. So that's going to go into my local settings JSON file here. So let's just go and add that in while we're here. And for now, just to prove that the simple reverse proxy works locally, it's going to proxy across to localhost 7071. When we deploy to Azure, we will set this up in the Azure portal, and this will point to my public IP address and quadruple 8 as the port. We can save that and close that. And then let's carry on with this function. So we've got our host environment variable, but let's just do some check-in to make sure that we have configured that correctly. And again, if we haven't, then we'll send back an error. Then we can start making our call to our API. So we need a new HTTP client. Let's add in the right usings. Let's set the base address for our request to our host and /API, which is where our API lives. We can then create a message, and we use the same method, the same HTTP verb that's been sent in. So if it's a post, it will forward as a post. If it's a get, it will forward as a get. And we use our function to call that we got out of our query string up here as the function that we want to call. So then if it's a post only, because post will contain a request body, then we do that. So we get the request body and we set that up as the content of the message that we're forwarding across. We then make our call and we get the response back into an object here. And then we can go ahead like we have done with all our other Azure functions and create a corresponding response from that and put in that response body. So we send it back. So that's essentially just called an Azure function by calling this Azure function. So let's just run that up and prove that that works. So we can see that we've got our new simple reverse proxy function available to us. So I can come over to something like Thunder Client and put in a get request, give it a func equals, and the func I want to call is version. So I can see that I've got another API call called version down here. And if I send that in, I get back a 200 and the version information has been returned correctly. So my reverse proxy is calling back round to my own Azure API and calling a separate function. So that's all working, so that's good. So we can push this now up to Azure so that we get our reverse proxy functionality available in the cloud for us. So I'm going to go and do that, and then we'll come back and carry on. While that's deploying, we can jump over to the Azure portal and go to my static web app and the configuration settings. And you need to add a new configuration setting here. I've already done it. So we're adding our proxy API host that we had in our local settings. And as I said, you want to configure this to your public IP address and whatever port you're forwarding across to your particular API. So that's all now deployed. So I can go to my site that's up on Azure and go to the API, call simple RP and give it the func that I want to call, and we'll call the version again. And on my local environment, I've got my Azure functions up and running, and I've got a breakpoint in the version function. So let's give that a go. And I can see down here that Visual Studio is flashing at me saying that it's hit a breakpoint. So let's go, and we are inside of our function. Locally, we've got our request coming in. So I'm just going to let that run, jump back over here, and I can see the response has come back correctly from my local Azure function. So it's an internet facing reverse proxy that's calling my local development environment, which is nice. So that means I can now develop my API connector function locally and set up Azure B2C to call that reverse proxy. But we're going to get to all of that in a bit. So let's stop our API and let's go and start on our API connector function. So we're going to have a function called user permissions, which takes a post, and I am going to cut some tutorial corners here like most people do. We should really have some authentication going on in this particular function. So out of the box, B2C for API connectors supports basic auth or certificate auth. So you should be validating that authentication. I'm going to skip over that just for brevity of this tutorial because there's enough here to show you how this all works. So given that you are authenticated from Azure B2C to actually call this API, we can then get the request body as we normally do. And we are going to create this request connector class. So we're going to deserialize the request body into a request connector object, but we'll create that in a minute. We need to do some usual error checking. So if our request connector isn't correctly deserialized, then we have to return a set response from our API connector to inform Azure B2C to show a block page. So it stops the authentication at this point because our API function has failed, and we return that as a bad response. So, and if you want to see the information on where I got this from, so it's from this page over here. I'll put a link to this in the description, but it's about adding an API connector to the sign up user flow. Why sign up? I'm signing in and using it, but anyway, there we go. And there's this example responses section down here. So this is the example of a good continuation response. So this is what you should return if you want the login to continue along with your custom attributes that you're adding in. We'll get to that in a minute. So this is an example of what I was just put in there for the error. So we show a block page, we put our error message in and version. So if we jump back over, that's exactly what mine looks like. So that's our error handling. So at this point, you could perform any other validation that you want against the payload. Things like, does the client ID match? Is the email present, etc. You can do anything inside your Azure function, obviously. So add as much validation here as you want to make sure that the consumer that's calling this function is who they say they are. Once you've passed all the authentication and validation checks, you can then go and look up your custom claims that you want to add in. So I'm hard coding this here, but this might typically be a database connection lookup where you're going to find the person who's actually logging in. So you get this claim coming in the request connector, as we'll see in a minute. And at the moment, I'm just checking if that's admin, then I go and add the admin user role to the permissions. So everyone gets to be a user, but only the admin user gets to be admin, is my simple case here that I'm putting in. But obviously you can go and add in as many different types of user permissions as you want, and I'm comma separating them here. So they all go into the same custom property, but comma delimited. And then finally, the last thing that we need to do inside this function is actually set up that response with our custom claim in it. So we return a 200 response and we return our extra permission, which is from our user permissions, comma delimited string. And we've called that user permissions. It has to have the extension prefix on it. That's a B2C convention. So we have to adhere to that. And that's all we need to do for our Azure function. So let's go and create a new file in here, request connector, and let's just paste this in so that we can see what this does. So here's our request connector class, and so we can see that we've just got some properties in here basically, and we are renaming these so that they get deserialized correctly. So even though we've called it client ID, the JSON that will come in is client underscore ID. So we've renamed some of these locally inside this object, but essentially this is what gets passed in the step, the client ID, the UI locales, the email address, which is the all important one because that's what we're using as our ID to look up our permissions, the object ID, which is the Azure object ID for this particular user, and some useful other information like display name, given name, etc. So we can now jump over to Azure B2C in the Azure portal, and we need to go to this API connectors option here, and we add a new API connector. Give it a useful name, and we'll give it the name of our reverse proxy in here. And we can copy that from here and paste that in there, but we don't want the version function. We want user permissions, which is the Azure function that we just created. And we'll send in some basic, but we're not validating it, but we should be. Yeah, our usual secure credentials, and we'll save that. And then we've got to go to user attributes to add in our new custom attribute. So these are all the default ones. We're going to add in a new one. We're going to call it user permissions. If you remember, we had over in our Azure function, we called it user permissions here. So that has to match, and we'll make that a string, give it some useful description and create that. So now we have our user permissions down here, which is a custom type. And then we can go over to our user flow that we used for sign in. So we've got our sign in flow, and we can go to application claims, and we can add in and select that custom claim that we just added and save that. And then while we're in the sign in user flow, we go to API connectors. We can now see our user permissions function in here that's available to us, so we can select that, and that's how we wire up B2C to call that particular function when it's creating the claims. So as part of the sign in process, it will now call out to this API that we've configured. So let's run all this up and give it a test, and we'll put a breakpoint in our user permissions function just so that we can see that it gets hit. Okay, so our app is up and running, so we can, and this is our local one, so I'm running on localhost. I can sign in, I get redirected to Azure. Let's log in as the admin in this particular case. And let's sign in, and again I can see I've hit a breakpoint down in Visual Studio Code. So let's go and jump in there, and here I am inside my user permissions. So let's just step over some of this. So we get our request body. Let's go and have a look at that so we can see exactly what that looks like. And you can see that the email address is the admin as passed in. So let's carry on. So we add in our user permissions, but essentially I've got a user and admin as the user permissions that I'm sending back. So let's just run these through, and we'll probably find that my authentication has failed because I've taken too long. So let's just, now that we've seen that's up and running and working, let's take that out, take the breakpoint out, and let's try that again so that it runs through as we would expect. And that has signed us in. And I've got some debug trace in here, so we can go and look at the ID token claims, and we can see there's my extension user permissions with user and admin being passed back in the token back to the Nuxt application, which is exactly what we want. While I'm there, let's just go and get the access token as well. And if we come over to jwt.ms and paste that in, we have a look at this here, we can see that we also get the extension permissions passed into the access token. So that means that it's available both to our client-side Nuxt application, but also to our Azure Function API when we pass in the access token. So that's really handy that it puts it into both tokens for us, because we can use that on both sides to make sure that the user contains the right roles to be able to do what they're trying to do. So that's all well and good, but we're obviously not taking any advantage of that. So how do we plug all this now that we're getting these extra user roles back into our Nuxt application? So let's get rid of the dev tools. Let's come back over here, and we know our function API is now working, so we can now close up the API side of this and start looking at the Nuxt side of it and how we can take advantage of some of this. So inside of our user store, we've got our auth user store. What we're going to do is add in a new getter in here, and we're going to ask if the user has a particular permission. So it's going to query the token that it's storing inside this store. So we have to pass in the required permission that we want it to test for, and that's going to give us back a true or false result. So inside here we can have an if test that says if we've got a current user and the user has the user permissions claim. So what we're going to do is we're going to look in the user permissions string, and we're going to see if it contains the required permission string that's been passed in. And if it does, we return true, so the user has that permission, and if it doesn't, we return false. And if we don't have a user, or the user doesn't have any user permissions claim in it, then we are just going to return false back out of this method. So let's save that. So then inside of something like our header component, and we can now, rather than always showing this admin link, let's change this so that we only show the admin link if you are in fact a user that's got the admin role. So we need to import the auth store in our script as we normally do, and then we can use the auth store to get out the user has permission getter. And once we've done that, that's then available to us inside of our Nuxt template up here. So we can put in the if user has permission and pass it the string of the role that we want the user to possess in order to show this particular Nuxt link. So let's save that. So that's our app up and running, and as we can see, we don't see the admin menu here. So let's go and sign in, and let's start by signing in as someone who's not the admin. So good old Arthur, just a general user. He can log in and welcome Arthur Dent, but he doesn't see the admin menu, but he does see restricted areas because he is logged in. So let's sign him out. Let's sign back in as the admin this time. The admin gets the admin user role, and so we see our admin link over here. So that's UI stuff inside of Nuxt that you can take advantage of the UI roles quite easily. But what about our API if we want to restrict things in our API? So let's jump back over here and we can get rid of these. So inside of our API, we've got our isolated function authorization. So we're going to go and make some changes to this to take account of the user role that gets passed in. So let's jump into the authorization middleware, and right at the top where we've got our scopes, we're also going to add in our roles claim type, which is extension user permissions. As we know, we saw that in the access token. And then we can change the authorize delegated permissions here. So last time I commented out about user roles and said I'm not interested in those, but I'm now going to change this so that it does take account of user roles, but it looks at my B2C extension. I'm going to look up the claim for the user permissions and split that by the delimiter, so comma and a space, and I'm going to remove any empty entries. So this will get me a collection of the user roles. Now that I've got a collection that I can use, I can query that collection to see if the role that's been specified against the Azure function exists for this user. So this user possesses the right role to be able to call the Azure function that they're calling. And we'll go and change the attribute that we put on the Azure function to state what role they need to possess in order to call it. So that's what this is doing here. We just need to change the last line as well, so that as well as checking the accepted scope, so exactly what it was doing historically, which is to check that the user has the role and the scope, we changed this last time. So I'm going to put it back to how it was. So now they have to have the role and the scope in order to call the function. So let's save that. And then let's jump over to our API, and we've got our B2C protected function in here that at the moment you have to have the email scope in order to be able to call this. So we are going to change this so that as well as email access, we give it a user role of some value. and let's say admin. So only admins can now call this B2C protected function. Let's save that and start this up. Okay, so that's up and running. So let's jump over here, and we're not signed in, so let's go and sign in, and let's do the same test that we did before. So let's sign in as someone who isn't admin. I'm going to put on the developer tools. So we can see there that my B2C protected function gave me back a 403 forbidden because he's not an admin role. So then let's sign out and sign in as admin. And this time we get a 200 for our B2C protected function, and we see our data on the page. So that shows how you can protect your Azure functions as well and make sure that the people that are calling them have the right roles in order to be able to call them. So that's front end and back end secured with user roles using Azure B2C. So if you found this useful, please do hit the like button. That helps it find more people. And with that, I want to thank you very much for watching, and I will see you in the next video.